Largest common subsequence, in short, LCSS, is the most common problem we learn when learning data structure. In this video, we are going to learn to explore it from a time series perspective. In its basic form, the objective is to find the largest common subsequence between two strings. For example, given two strings as highlighted in this image, LCS can be found by the path highlighted in yellow line. And whenever the number is changed, we get the character of interest. The algorithm is pretty straightforward. With the complexity of n square, you can iterate over two lists, and if the element matches, then just add plus one to a number in the previous diagonal. If they don't match, choose the max between top and left and retain the arrow from when the number is copied. When you reach at last diagonal, the arrow will give us the whole access path. We can just backtrace it. We can replace string with any time series information. For example, in given map, finding the largest common route taken by different vehicle to obtain the critical area requiring infra update. Use cases can be many, but the underlying problem or principle is that it's a time series problem. Now, since LCS is a 0 1 problem, as you know, by the string example, meaning either elements are similar or they are not. So we need a way to measure similarity between time series which contain numerical information. So if distance between 2 points x and y is smaller than epsilon, they are considered to be equal and their distance is reduced to 0. In the opposite case, if the distance is greater than the epsilon, they are represented with the value 1. Now, distance metric could be any, it could be Euclidean or any other custom metric. So, let's take an example. First, we are going to import over the library. Then, we are going to create two random time series with size of 100 and dimensionality 1. Once the time series are created, we are going to rescale them so that they have mean 0 and standard deviation 1. After that, we just put them into a data frame. So as you can see, we have two time series denoted by x and y. And if we are going to visualize those, we can just plot them using CSS. And we have our two time series, x and y, denoted by a blue and orange line. So now, we need to compute some score, like how similar are these two time series with each other. So we just compute an LCS score using the metric LCSS, and the score we obtained is 0.82. But the aim of this whole experiment is to find the optimal or largest common subsequent path between these two time series. For that, we are going to use an inbuilt function LCS interval path. So it's going to give us both the score as well as the path. So this is a single largest path as identified by the algorithm. So here, if you look closer, you will see that it contains two values. Like every index contain two values. So what that means is this LCS part, the first element is zeroth element of first time series, which is x, and the 15th element of second time series, which is y. And then the second element in this path is the first element of x and 16th element of y, and similarly go on. So if we plot this path and overlap it with our existing time series, what we get is an LCS path. So here you can see like this path is mapping here, this is mapping here, this is mapping here, and so on. So what we obtained is the LCS representation, or rather the largest common subsequent path between these two time series.